spaceships, powered by antimatter,
Mm-hmm.
like in Star Trek. Pretty cool.
Yeah.
Well, today we're going to do a deep dive on the tiny particle that makes antimatter real.
Mm-hmm.
Positrons. You sent me some fascinating research on this, so I'm excited to dive in.
Yeah, this will be fun.
So, okay, positrons. Basically, they're the antimatter version of an electron.
Right.
They have the same mass, but instead of a negative charge, they have a positive charge.
Mm,
And that tiny little difference has huge implications.
you got it. That's that positive charge is what makes them antimatter.
Okay.
And that's what makes things really interesting because, well, when matter and antimatter meet,
Yeah.
they annihilate each other. Just poof, in a burst of energy.
Annihilate, that sounds intense.
It is. Think of it this way. If an electron and a positron high-fived, they would both disappear in a flash of pure energy.
Wow.
That energy, by the way, that's in the form of gamma rays.
Okay.
And that's what makes some pretty amazing applications possible.
Yeah.
But before we get into that, the
Yeah.
story of how positrons were discovered is pretty wild.
Oh, I love a good origin story. So what's the scoop?
Well, in 1928, there was this physicist named Paul Dirac, and he predicted the existence of positrons, get this, just using math.
Wow.
But it wasn't until 1932 that Carl Anderson actually observed one while studying cosmic rays.
Oh, wow.
He used a cloud chamber. You know what that is?
Remind me.
It's this cool device that lets you see the tracks of particles.
Right.
And there it was, a particle that behaved just like an electron, but it curved the opposite way in a magnetic field, meaning
Okay.
a positive charge.
So Dirac, he basically called it years before we even had the tools to prove him right.
Exactly. It was huge, validated Dirac's theories, and Anderson won a Nobel Prize for it.
Wow.
This was the first time anyone had actually seen antimatter, proving it wasn't just some theory.
Right.
And, well, it just opened up this whole new world of possibilities in physics.
I bet. So this matter-antimatter annihilation thing,
Yeah.
it's not just a cool physics phenomenon, is it?
Uh-huh.
This is where we get into medical imaging.
You got it. Remember those symbols you might have seen, E plus or La plus A?
Oh, maybe vaguely.
These are positrons.
Mm.
And they're at the heart of what's called positron emission tomography,
Okay.
better known as
PP scans.
CT scans, exactly.
So how do we go from positrons and annihilation to seeing inside the human body?
Right.
It's not like doctors are injecting people with pure antimatter.
Oh,
right?
no, that wouldn't end well. PET scans use what's called a radioactive tracer
Uh-huh.
that emits positrons.
Okay.
This tracer is injected into the body, and as the positrons travel through the body, well, they eventually bump into electrons in your tissues.
And then that's when the fireworks happen.
Exactly. When the positron and electron annihilate, they release those gamma rays we talked about. And doctors can use special scanners to detect these gamma rays, which are basically high-energy light, and that's how they create detailed images of your organs and tissues.
Oh, so it's like those gamma rays are sending signals from inside the body,
Yeah.
letting doctors see what's going on.
Yeah, pretty neat, huh?
Very ingenious.
It is. PET scans are incredibly valuable for diagnosing and monitoring all sorts of conditions, from cancer to heart disease to brain disorders.
Wow.
And it all comes down to, well, understanding this fundamental interaction between positrons and electrons.
It's mind-blowing to think that we're using antimatter to improve healthcare.
It really is. And that's just the beginning. PET scans are just one application of positrons. There's a lot more to this tiny particle than meets the eye.
Okay, now you've got me really curious. What else are these positrons up to?
Well, let's see. They're making waves in materials science and fundamental physics research as well. In fact, you could say they're helping us build stronger materials and even unlock the secrets of the universe.
Hold on. Stronger materials. How do positrons fit into that?
Imagine you're building an airplane.
Okay.
You want the materials to be as strong and lightweight as possible, right? Positrons help us analyze those materials at the atomic level to find any, hidden flaws or weaknesses.
So they're like tiny little quality control specialists.
Exactly. And this technique, it's called positron annihilation spectroscopy. It lets us see things we couldn't otherwise, leading to safer and more efficient materials.
I'm starting to realize that these positrons are a lot busier than I initially thought.
Uh-huh.
They're in our medical scanners, they're helping us build better stuff, and they hold the key to unlocking the power of antimatter.
It's true.
What else can they do?
Well, they're also shedding light on some of the biggest mysteries in physics.
Okay.
By studying positrons, we're learning more about, the fundamental forces of nature, and even the origins of the
Okay,
universe.
now we're talking about the big stuff.
We are. We were just talking about positrons helping us understand the universe.
Yeah.
Well, they're actually being used in some of the most cutting-edge physics experiments in the
Yeah.
world,
Yeah.
like at the Large Hadron Collider.
Oh, wow. That's the one in Europe, right?
Hmm.
Where they smash atoms together at, like,
Yeah.
really the speed of light.
Yeah.
What do positrons have to do with that?
Well, that's the one. It's a giant particle accelerator, and it helps us study the fundamental building blocks of matter.
Right.
And in some experiments, they actually use positrons, smashing them head-on into electrons at incredibly high speeds.
Wow. I can't even imagine the energy released in those collisions.
It's a lot.
So what do physicists learn from watching these, like, subatomic crashes?
Well, these collisions, they create conditions similar to those just moments after the Big Bang.
Wow.
So it helps us understand what the universe was like in its earliest stages. It's like using a time machine to study the birth of the cosmos.
So positrons are giving us a glimpse into the very beginning of everything.
In a way, yeah.
That's amazing. So remember we were talking about antimatter propulsion and spaceships?
Yeah.
Could positrons really be the key to interstellar travel?
Well, it's a long shot, but the idea is that the enormous energy released during positron-electron annihilation,
Right.
that could be used to propel a spacecraft.
Okay.
It would be the most efficient fuel source imaginable.
I can see why scientists are so intrigued by that idea. But I imagine there's some pretty big challenges to overcome before we start,
Oh, yeah.
booking our flights to Alpha Centauri.
Of course. The biggest hurdle is that antimatter, including positrons,
Yeah.
it's incredibly rare in the universe.
Mm-hmm.
And even producing tiny amounts of it in labs requires a massive amount of energy.
Yeah.
And it's super expensive.
So it's not just a matter of building a bigger engine. We need a reliable source of antimatter first.
Exactly.
Oh.
But that doesn't mean it's impossible. Scientists are always working on, new techniques to produce and store antimatter more efficiently.
Right.
It might take decades, even centuries. But the potential payoff is huge.
It's like those early inventors tinkering in their workshops, dreaming of flying machines.
Yeah,
Who knows? Maybe someday we'll be soaring among the stars thanks to positrons.
maybe.
Speaking of pushing the boundaries of technology, you mentioned earlier that positrons are also making a splash in the world of quantum computing.
Yeah, they are.
Okay, and this is where things get really mind-bending for me.
Uh-huh.
So how do positrons fit into the world of quantum computers?
Well, quantum computers they're radically different from the computers we use today.
Okay.
They basically harness the strangeness of quantum mechanics to perform calculations in ways that seem almost, magical.
Right.
And positrons, with their unique quantum properties, could be crucial to making these computers even more powerful.
Quantum mechanics already sounds pretty strange to me.
Yeah.
What makes positrons so special in this context?
Okay, so think of it this way. In a normal computer,
Yeah.
information is stored in bits, which can be either a 0 or a 1.
Right.
But in a quantum computer, information is stored in qubits, which can be both a 0 and a 1 at the same time.
So it's like a light switch that can be both on and off at the same time. How does that even work?
It is a bit hard to wrap your head around, but it's a real phenomenon in the quantum world. And positrons, because they are antimatter,
Right.
they have these unique quantum properties that make them, perfect for creating and controlling these qubits.
Okay.
For example, their spin, which is a quantum property related to their angular momentum,
Right.
that can be used to store information.
So we could be using positrons to build the brains of these super powerful quantum computers.
Potentially.
That's incredible. But what kinds of problems can these quantum computers solve that our current computers can't even touch?
Well, they have the potential to revolutionize fields like medicine, material science, and even artificial intelligence. Imagine designing new drugs with pinpoint accuracy, or creating materials with unheard of properties, or even developing AI that can solve problems we haven't even thought of yet.
It sounds like positrons are not just helping us understand the universe, they're helping us build a better future right here on Earth.
I think so.
It's amazing to think that something so small could have such a huge impact.
It really is. And it's a testament to the power of, scientific curiosity.
Yeah.
By studying, the seemingly esoteric world of subatomic particles, we're opening up entirely new avenues for innovation and discovery.
It's a good reminder that even the smallest things can make a big difference.
They really can.
So we started with this tiny particle, this positron,
Right.
and now we're talking about like revolutionizing medicine, space travel, even the way we process information with quantum computers.
It's amazing, isn't it? It really shows you how fundamental research can lead to these unexpected breakthroughs. We often don't know where a scientific discovery will lead,
Right.
but by pursuing knowledge, just for the sake of it,
Yeah.
we open up all sorts of possibilities.
And in the case of positrons, those possibilities seem pretty much limitless. We've talked about the potential of antimatter propulsion. But are there any other futuristic applications, on the horizon?
Well, one area that has researchers really excited is using positrons for advanced cancer therapy.
Oh, wow.
Imagine being able to target tumors with incredible precision, delivering like a lethal dose of radiation directly to cancer cells while sparing the surrounding healthy tissue.
That would be incredible. A game changer for so many people.
Absolutely.
It sounds like something out of science fiction, but it's based on the real science of positrons.
Exactly. And it really speaks to the ingenuity of scientists and engineers, constantly finding new ways to harness the power of these particles.
Yeah. Who knows? Maybe someday we'll even have portable PT scanners,
Right.
thanks to, advances in miniaturization and antimatter production.
It's possible.
Wow. A PET scan that you could do anywhere. That would be incredible. It's amazing to think how far we've come since the discovery of the positron.
Less than a century ago.
Yeah, less than a century ago. From that initial aha moment to all these futuristic applications, it's been quite a journey.
It really has. And we're still just scratching the surface of what's possible with positrons and antimatter. So many mysteries left to unravel. Like, one of the biggest questions in cosmology is why there's so much more matter than antimatter in the universe.
Oh yeah, that's a good one.
Theoretically, they should have been created in equal amounts during the Big Bang,
Right.
but where did all the antimatter go?
Yeah, it's like the universe is missing half of its puzzle pieces.
Right.
So do they hold any clues to solving that mystery?
They might. By studying positrons and how they behave, we're getting a deeper understanding of the fundamental laws of physics
Right.
that govern the universe. And those insights, well, they might help us explain the matter-antimatter asymmetry and, other cosmological puzzles.
It's really incredible to think that these tiny particles, invisible to the naked eye, could hold the keys to understanding these grand mysteries of the cosmos. It reminds you that there's so much more to discover, even in the seemingly empty spaces between atoms.
Absolutely. And that's what makes science so captivating. It's a constant process of exploration and discovery, pushing the boundaries of what we know and challenging our assumptions about the nature of reality.
It really is.
And positrons, with their unique properties and potential applications, they're playing a starring role in that adventure.
Well, I think we've given our listeners a lot to think about today. You've gone from maybe knowing a little about positrons to understanding their fundamental properties, their role in medical imaging, and their potential to revolutionize fields like space travel and quantum computing.
Yeah. Hopefully, this deep dive has sparked your curiosity about positrons and, well, the world of antimatter.
Yeah, for sure.
It's a fascinating field, really endless possibilities.
Endless.
Who knows, maybe someday you'll be the one making groundbreaking discoveries in this area.
And if you ever need a refresher on the basics, you know where to find us. Until next time, keep exploring.